Hello children, in our last discussion we came to know about potential due to a point charge, that is V at R equal to Q by 4 pi epsilon naught R. After that, potential due to dipole, potential due to a system of charges. After that, today we will discuss equipotential surface, which is one of the core area in this unit. First of all, what is the equipotential surface? A surface with constant value of potential at all points on the surface. Let us see here, it's a positive charge, so electric field is radially outward. So at this point, potential will be kq by this distance. So if this distance, let it be r, then at distance r, every point that will be potential will be same. So this surface is equipotential surface. Today we will discuss relation between field and potential, properties of equipotential surface. First of all, once again, start with equipotential surface. Equipotential means equi plus potential. So a surface at every point of which the potential due to charge distribution is the same is known as equipotential surface. Let it be equipotential surface for some charge configuration. First, for a uniform field, means charge is very far away, then the field lines are parallel. So at any point, here if we see, this surface is of equal potential, this surface of equal potential, this surface of equal potential. Let it be here the potential is V1, here V2 and V3. So these three surfaces are a plane of equipotential surface. But remember, V1 is not equal to V2 is not equal to V3. Next, for an isolated charge, the equipotential surface is a spherical. Next, equipotential surface for a dipole. In the dipole, see here, for a dipole, positive and negative charge, field lines originate from positive charge, ends on negative charge. See the equipotential surface. It is not complete spherical because here the field lines will move density. So here this side surfaces are close, but this side if you see surfaces are far away. Then the equipotential surface for two identical positive charge, again due to here this side repulsion, force of repulsion, equipotential surface are far, this side here the close. For two identical negative charge, equipotential surfaces as here. Now what is the relation between electric field and potential. Here A and B are two closed equipotential surfaces. Let the potential at A, potential on this surface is V, potential on surface V is V plus del V. It is the difference in the potential between A and B. At point P, electric field direction is, let it be as shown. And now if a unit positive charge is brought from B to A, means against the electrostatic field, then work done to bring unit positive charge from B to A will be potential. And we know the work done to bring a unit positive charge from one point to another point at distance, here we are taking del L, is line integral E dot dl, and it is nothing, it is simply the potential difference. So what will be E dot dl equal to V, means charge, unit positive charge is brought from B to A, so final potential V minus V plus del V. So that's value will be minus del V. So what will happen? So here see work done to bring the charge B to A will be VA minus VB, or E dot dl equal to VA minus VB. So E equal to minus del V by dl. From this, earlier we came to know the unit of electric field, that is Newton per coulomb, force per unit charge, and here potential difference per unit length. So its unit will be volt per meter. Again from this equation 3 we can draw some important conclusion, that is electric field is in the direction in which potential decreases steepest. Its magnitude is the change in the magnitude of potential per unit displacement normal to the equipotential surface at that point. Here we are taking normal. Later on, while we will discuss its properties, this point will be more clear. Now some properties of equipotential surface. First, no work is done in moving a test charge from one point to another on an equipotential surface. Here, let this surface for this charge will be an equipotential surface. So here the potential is VA, here the potential is VB, but magnitude of this will be 0, and we know work equal to potential difference. So work will be 0. Second property, the electric field is always perpendicular to the element dl of the equipotential surface. Let it here, since no work is done on equipotential surface, now use here this formula, work done to bring the charge A to B is negative of it is the work done by the electric field. So that will be A to B, and negative E dot dl equal to 0, and dot product is, if we remember the class 11, dot product A dot B equal to AB cos theta. So what will be this value? From point 1, this work done is 0. So surface integral E dot dl equal to 0, means E dl cos theta equal to 0. So cos theta equal to 0 means theta equal to 90 degree. Means the electric field is perpendicular to the element dl of the equipotential surface. Next is, equipotential surfaces indicate regions of a strong or weak field. What we have seen there, E equal to minus del B by dl. Negative, and dV by dl is the potential gradient. So electric field is negative of potential gradient. Children, electric potential is a scalar quantity, but potential gradient is a vector quantity. Just we have discussed earlier, E equal to minus dV by dr. So dr equal to minus dV by E. Now for the equipotential surface, dV is constant. So what will be? dr is proportional to 1 by E. If E is strong, so from this relation, if E is strong or large, dr will less. That is, the separation of equipotential surface will be smaller. And if this one is less, dr is more. Next property, two equipotential surfaces cannot intersect. If they intersect, then at the point of intersection there will be two values of electric potential, and at any point there is only one potential. And also such property we got in electric field, that two field lines cannot intersect each other. Next, we will learn potential energy of a system of charges, that is for one charge, for two charge, for many charges. Then we will learn potential energy in an external field. Means if already a field is present, and every year one question from this part, especially potential energy of a dipole in an external field. After that, electrostatics of conductors, and then dielectrics and polarization, and at last capacitors and capacitance. Thank you for today. Next day we will discuss